Hey everyone, welcome back to another math video. In today's math video, we're going to learn how we can use perpendicular bisectors to form what we call a circumcenter in a triangle. Let's go ahead and let's get started. So here we have a triangle. What a circumcenter is when we use a perpendicular bisector on each of the sides of the triangle and we connect them in the center of the triangle. So for example, what we do is we take each side. I'm going to start with the bottom side of this triangle, and I come up 90 degrees. I make a 90-degree angle in the middle. We're assuming these would all be in the middle. Okay, they're probably right exactly in the middle, and it's probably not exactly a 90-degree angle, but I'll do my best. And we do this to each side. So let's say I want to go through the middle here on the left side at a 90-degree angle, and also on the right side of the triangle at a 90-degree angle. The point where these meet is what we actually call the circumcenter. Okay, so if I erase a little bit here, do a little bit of erasing. So this point in the center where these meet, that right there is what we call the circumcenter. Okay, now we're going to look at a better drawing right now where you're actually going to see what parts of the triangle actually end up, what it does to the triangle. Okay, because you're going to see that certain parts of the triangle are now equal to each other. This point is an equal distance away from certain parts. So let's go ahead and look at an actual drawing that's labeled. So we do this by using perpendicular bisectors. They are what connect the circumcenter. Now, when you make this, you end up cutting all of your sides into two equal pieces. So I can see here the bottom side has two equal parts. Left side, side BC, also has two equal parts, and side AC also has two congruent parts. The other part that you see stated there in the bottom is that this point P, which is what we call the circumcenter, is equidistant from all the vertices, meaning it's the same distance away from A, B, and C. So if I were to draw a line, in other words, if I were to connect B to P, A to P, and C to P, these would all be the same exact distance. That is the other thing that is special about this point. And we're going to use the circumcenter and some of its properties, some of these things that are congruent, to help us solve some questions. Okay, so let's go ahead and let's begin by looking at some questions that have to do with the circumcenter. So here I have a question that says the perpendicular bisectors of ABC are PT, QT, and RT. Find each of the values. So here we have point T, which is the circumcenter. Point T, right there in the middle. And it's saying our perpendicular bisectors are PT, so from P to T, from Q to T, and from R to T. So those are our perpendicular bisectors. Alright, so based off of what we know, they want us to find what is the value of AT. So from A to T, that is the distance between one of the triangle's vertex, one of the triangle's edges, A, to the circumcenter. And as we saw in the previous diagram, every single point on the triangle of the edges, so A, B, and C, are the same exact distance away from T. So AT is actually the same distance as BT and CT. So these three in blue are actually all the same distance. Therefore, if we know what one of them is, we know what all of them are. And I can see here that they gave us what CT is. They said CT is 6, which means AT also has to be 6. Now let's look at RC. RC is this bottom piece of the triangle. Well, because it was cut by a perpendicular bisector, we know that this piece in particular is congruent to this piece. So AR is the same distance as RC. So if AR is 5, that means that RC also has to be 5. So this question wasn't too bad. Sorry, that's a 6. I meant 5. This question wasn't too bad at all. Alright, let's go ahead and let's look at another one. Now here they give us our diagram, and they've actually were nice enough to go ahead and label all of our congruent parts. Okay, again, we see point Q in the center is our circumcenter. So let's go ahead and read the question. It says, if xy equals 24 and xz equals 22 and jq equals 5, find the values. Round to the nearest tenth. So they want us to find this value of qk. They are looking for this value right here, this distance from Q to K. So what we end up doing is we are going to go ahead and label all of the other parts. XY in this case would be this long piece. That is 24. XZ is 22, and J to Q, from J to Q, we know this distance is 5. So this problem is quite special because in order to find QK, I need to make use of the Pythagorean theorem. And also what we need to do first, even before that, is we need to take the information they gave us and break it up to a way that it's more useful. So for example, they told me that XY is 24. I'm not really going to use 24. That piece of information doesn't mean much to me. But what I can find useful is if this was 12 and this was 12. The 24, that's what it was given to us for. In the same way, 22, they told us that x to z was 22, but really that's another way of saying that this piece is 11 and this piece is 11. And then jq was 5. So what we're going to do here is we're going to go ahead and we're going to use Pythagorean theorem, because what we really want to know is I need to know what the length is of all of these vertices to the circumcenter. These are all the same length. And this, if we know one of them, then we can use this Pythagorean theorem to find out what QK is on one of these lower triangles. But first, we actually need to find what is the length of that. And we can use one of these two triangles to help us find it. So first, let's focus on this highlighted portion of this triangle. Let's just look at this triangle. I have 12, 5, and the hypotenuse. So remember, C is the hypotenuse and 12 and 5 are my legs. So that means I can actually plug in 12 squared plus 5 squared, and this will get me that hypotenuse. 12 squared is 144 plus 25, which is c squared. I get 169 equals c squared. I can then take the square root of both sides, and I end up finding that 13 is in fact C. Now that we know that this is 13, I can tell that this will also be 13. And then I can repeat the whole process of the Pythagorean theorem, but this time I'm focused on this lower triangle. And it'll allow me to solve for QK, because I know the hypotenuse, I know one of the legs, QK is the missing leg. So now I'm looking for QK, which I'm going to just say that'll be a squared, plus 11 squared plus 13 squared, or no, equals 13 squared, because that's our hypotenuse. And we can solve this. We get a squared plus 121 is equal to 169. We can then subtract 121 from both sides. We end up getting a squared is equal to, and you subtract this correctly, you should get 48. And we get a equals the square root of 48. And that'll be because we squared both sides to get rid of that square. And if you want to round it, you can. I'm going to go ahead and just leave it at that. And I know, or you know what, why not? Let's go ahead and figure out what this is. We do the square root of 48, and it should be somewhere around 6.9. So hopefully now you're familiar with what a circumcenter is and how we can make it, how we can find it, and how we can use it. If you got it locked down in your head, awesome, and hopefully you got a little review on the Pythagorean theorem. So stay tuned for another video where this triangle in particular, the circumcenter, was formed by taking perpendicular bisector to each of the sides. In this next video that we cover, we're going to talk about what happens, what do we call the point that we get when we actually instead bisect the angles. Okay, it's an angle bisector that we draw inside the triangle. So stay tuned for that. And as always, thanks for watching. I hope you learned something new.